Hello everyone, welcome back to the channel. In today's video, I am going to show you exactly how to create a template in the Blynk app for ESP8266. It's super simple, and by the end of this tutorial, you'll be controlling your ESP8266 like a pro. So, without wasting any time, let's get started. Step 1. Blynk Setup. First things first, open your browser and search for blynk.io. Now, if you already have an account, simply click on Login. But if you're new here, no worries. Just click on Sign Up and register with your email ID. Step 2. Developer Zone. Once you're logged in, look at the left-hand side of your screen. You'll see Developer Zone. Click on that. Now, we are going to create a new template. Click on Create New Template. Step 3. Creating virtual pins. Here's what we are going to do. I'm creating 2 virtual pins for this project. The values will range from 0 to 1, basically on and off states. So, go ahead and add your data streams. Click on New Data Stream, select Virtual Pin and create V0 and V1. Step 4. Adding device. Next step, go to Devices section and click on From Template. Select the template name that you just saved. Click on Create from Template. Now comes the interesting part. 1. Template name. 2. Template ID. 3. Authentication token. Keep these handy, you'll need them later. Step 5. Setting up your dashboard. Go to the dashboard and click on Add Widget. If you found this video helpful, don't forget to like, share and subscribe to the channel for more amazing IoT tutorials. Drop your questions in the comments below and I'll see you in the next video. Now select the switch widget. Click on the switch settings and connect it to the data stream. Let's connect the first switch to V0. Similarly, add another switch and connect it to V1. Save your configuration. Step 7. Mobile app setup. Now grab your mobile phone and download the Blynk IoT app from Play Store or App Store. Log in using the same email ID that you used on the website. Step 8. Mobile configuration. In the app, go to Settings and add a button widget. Connect this button to the virtual pin V0. Since I've created 2 virtual pins, I am adding one more button and connecting it to V1. Make sure to switch the button to switch mode in the settings. And that's it guys, you've successfully created a Blynk template for ESP8266. Now you can use these virtual pins to control your ESP8266 from anywhere in the world. Alright guys, now let's move to the coding part. In this section, I'll show you exactly how to program your ESP8266 or Node MCU using Arduino IDE to control any appliance, whether it's LEDs, relays, or any other device. Let's jump right in. Step 1. Arduino IDE Setup. First, open your Arduino IDE. Now go to File, Preferences. Here you need to add the ESP8266 Board Manager URL. You'll easily find this official link on Google. Just search for ESP8266 Board Manager URL and copy the official link. The link also given in description box. Paste this URL in the Additional Boards Manager URLs field and click OK. Now some files will start downloading in the background. These are the necessary files for ESP8266 support. Step 2. Installing ESP8266 board. Next, go to Tools, Board, Boards Manager. In the search box, type ESP8266. You'll see the first option, ESP8266 by ESP8266 Community. Click on Install. Wait for it to complete. This might take a minute or 2 depending on need. Step 3. Installing Blynk Library. Now let's install the Blynk library. Go to Tools, Manage Libraries. Search for Blynk in the Library Manager. Install the first one, Blynk by Vladimir Shimansky. This will download and install all the necessary Blynk libraries. Click Install All if it asks for dependencies. Perfect. Now we are ready to code. Step 4. Selecting the board. Go to Tools, Board, ESP8266 Boards. Select Node MCU 1.0, ESP12E module. This is the correct board for most Node MCU ESP8266 boards. Now let me explain the code line by line so you understand exactly what's happening. First, the template configuration. Define Blynk template ID, define Blynk template name, Define Blynk auth token. Remember those 3 codes we saw earlier in the Blynk dashboard? Template ID, template name, and auth token? This is where we use them. Copy these values from your Blynk web console and paste them here. Next, the library includes. Here we are including the Wi-Fi library and Blynk library for ESP8266. The Blynk print serial line helps us see debug messages in the serial monitor. Wi-Fi credentials. Replace HR32 with your Wi-Fi name and 1234531 with your Wi-Fi password. This is how your ESP8266 will connect to the internet. Virtual pin V0 control. This function listens to virtual pin V0. Whenever you toggle the switch in the Blynk app, it reads the value 0 or 1 and writes it to GPIO5, which is pin D1 on Node MCU. Simple, right? Virtual pin V1 control. Same logic here. This controls GPIO4, which is pin D2 on Node MCU using virtual pin V1. Setup function. In the setup function, we start serial communication at 9600 baud rate. Initialize Blynk with our credentials, set GPIO5 D1 and GPIO4 D2 as output pins. Loop function. The loop is super simple. Just run blynk.run continuously. This keeps the ESP8266 connected to the Blynk server and listens to commands. Step 6. Uploading the code. Now select your COM port from Tools/Port. First click on Verify to check if there are any errors in the code. If everything looks good, click on Upload. Wait for the upload to complete. You'll see Done uploading when it's finished. Step 7. Hardware connections. After uploading is complete, press the RST button on your ESP8266 to restart it. Now let me show you the hardware setup. Since we are using 2 virtual pins to control 2 devices, I've connected 2 LEDs. LED 1, positive terminal to D1 pin, negative to GND. LED 2, positive terminal to D2 pin, negative to GND. You can also use relays instead of LEDs to control high-voltage appliances like bulbs, fans, etc. Testing on mobile app. Now open your mobile phone and launch the Blynk IoT app. You'll see the same template you created on your laptop with 2 switches. Toggle the first switch, LED 1 turns on and off. Toggle the second switch, LED 2 turns on and off. Amazing, right? You are now controlling your ESP8266 from anywhere in the world through the internet. Conclusion. And there you have it, guys. You've successfully set up Arduino IDE for ESP8266, written and uploaded the code, connected LEDs to your Node MCU, controlled devices from both web and mobile app. Now you can use this same concept to control relays, motors, lights, literally any appliance you want. If you don't see any port listed here, don't panic. This is a very common issue. If your ESP8266 port is not showing up, you need to install the CH340G driver. Let me show you how. Step 1. Open Google and search for CH340G driver download. Step 2. Click on the official link, usually from the manufacturer's website or a trusted source like SparkFun or Arduino's official documentation. Step 3. Download the driver file according to your operating system. For Windows, download the Windows version. For Mac, download the Mac version. For Linux, download the Linux version. Once downloaded, extract the file if it's in a zip format. Run the setup or installer file and follow the installation steps. It takes just a minute. After installation is complete, restart your Arduino IDE. Now disconnect and reconnect your ESP8266 to the USB port. Go back to Tools, Port, and you'll now see your COM port listed. Perfect. Your ESP8266 is now detected.